Hey y'all. I know I'm upside down, but I'm going to record using your notes. So make sure you have your outline. And I'm going to show you how to graph an equation using slope-intercept form. We've learned already how to graph equations by setting up a table. And I've also shown you how to graph equations by using the x and y intercepts. So another way to graph an equation is if the equation is in slope-intercept form, which is y equals mx plus b, m being the slope of the line and b being the y-intercept. The y-intercept is where it crosses the y-axis. So if you have an equation that is in slope-intercept form, it's one of the, in my opinion, it's one of the easiest ways to graph the equation. Just a little reminder, slope is rise over run. Remember, we count vertically and then horizontally. And the slope can be positive, negative, 0, or undefined. If it is a positive slope, it's going to slant in the direction that we read from left to right. It's going to slant up. If it's a negative slope, it's going to slant down. A 0 slope is a horizontal line. A horizontal line is a 0 slope, and an undefined line is a vertical slope. It's just a review. And of course, we already said B is the y-intercept, where it crosses the y-axis. There are just a couple steps to graphing an equation in slope-intercept form, and so we're going to start with example 1, y equals negative x plus 7. First thing you need to do is identify your slope and y-intercept, your m and your y-intercept. So my y-intercept is plus 7, so my y-intercept is 7. And my slope is this negative 1 because it is in front of the variable. Remember, if there's no number in front of the variable, you can put a 1. And since this has the negative sign, it's negative 1. Now, because slope is rise over run, we want to kind of think in terms of fractions. So negative 1 over 1. We're going to rise over run. If your slope is a whole number, then your denominator is going to always be 1. It's important to make sure you understand that it's two parts of slope, rise and run. And then my point for my y-intercept is 0, 7. Once you know those two things, then you can graph a line. We're going to start with the y-intercept. So just make a note. Start with the y-intercept. We're going to plot that point first. 0, 7. 0, 7. You start with your y-intercept, and then, so number 1, start with our intercept, and then you count your rise over run. We're going to count our slope. Now, in this example, our slope is negative 1 over 1. We know we're going to have a negative slope, so we're going to have a descending line, a decreasing line. It should be going down. We're going to go down 1 and then over 1. Down 1, over 1, down 1, over 1. And you see the pattern is going to continue because the slope is rise 1, run 1. So 1 to 1, 1 to 1. And after you plot a few points, you connect your lines, you extend your arrows, and I have graphed this equation. Y equals negative x plus 7. Let's go to example 2. Graph 2y equals 3x minus 10. Well, this is not in function form. It's not in slope-intercept form. A while back I told you when you put it in function form, I always told you to put the x value first, and now you can see we need to put it in slope-intercept form. So I'm going to come over here, you do it too, and we are going to put this equation in slope-intercept form. To do that, my y is already opposite of my x on separate sides, so I just need to divide by 2, and y is going to equal 3 over 2x, and 10 divided by 2 is 5, so minus 5. Now I can identify my slope is 3 halves, and my y-intercept is negative 5. And remember, it's negative because of the minus in front of it. My slope means I'm going to rise 3 and I'm going to run 2. It's a positive, so I know I want to have a positive line. It's always best to kind of visualize your graph before you do it. And my y-intercept is negative 5, so the coordinate, the ordered pair is 0, negative 5. Remember, we start here. I'm going to plot 0, negative 5 on my graph. And then I'm going to count rise over run. I want a positive graph, so I'm going to go up 3, 1, 2, 3, over 2. Up 3, over 2. Up 3, 1, 2, 3, over 2. Once I have a few points, I can connect and draw my arrows to indicate that the line is going to go on and on. So this is, again, you have to put it in y equals mx plus b form. You need to put it in slope-intercept form first, then identify your slope and y-intercept. All right, go to the back. My gel pen is kind of what's the word, like, I don't know, spreading. I don't know what the word is. Rubbing. Example 3, graph negative 3y minus 4x equals negative 12. Again, I need to put it into slope-intercept form. So I'm going to rewrite my equation. My x and y are on the same side, so I need to move my x over. I'm going to add 4x to both sides. And remember, we want to put our x term first. So the 4 is positive, the 12 has the minus, so it's minus 12. I need to divide everything by negative 3. I get negative 4/3, and remember, you leave it as improper fraction, and a negative 12 divided by negative 3 is going to be a positive 4. Here is my equation in slope-intercept form. Make sure you can see it, sorry. Now I have my slope is negative 4/3, and my y-intercept is 4, which is going to be 0, 4. Now remember, slope is rise and run. So this is negative. So I'm going to have a negative line, a decreasing line. I start at my y-intercept, so 0, 4. Always start at your y-intercept because that's your point. You can't start at the slope because that's not a point. You have to start at your ordered pair, which is the y-intercept. Now we're going to count down and then to the right 3. So I'm going to go down 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. You could keep going, but I've done 3 values, so I'm going to graph my equation, draw my arrows to indicate that it goes on, and I have just graphed this. Now, I just want to speak one moment about example 3. I just can tell, and I bet you can tell too, 3 and 4 are multiples of 12. So in this particular example, it may have been easier to graph using intercepts. Remember we practiced? You let x be 0, and you let y be 0, and then you find your intercepts. But we actually already found our intercepts because here's the y-intercept, and here's actually the x-intercept. I am just showing you, you can graph multiple ways, and eventually, hopefully, you'll kind of see, oh, this equation would be easier to graph using intercepts, but other equations would be easier graphing in slope-intercept form. So just showing you that you can do both ways. All right, our last part is special cases, when there's only one variable. All the other problems, we've had 2 variables, but this one we only have 1 variable. And these are either horizontal or vertical lines. If it is not in y equals mx plus b, then you might not be able to just pick the slope and y-intercept. So if it's x equals 4, I'm just going to remind you that all of the x values are 4 no matter what the y values are, negative 1, 0, 1, which means x equals 4, x is always going to equal 4. And you kind of see, oh, this is going to be a vertical line. That means that the slope is undefined. The slope is undefined, and there's no y-intercept. It is parallel to the y-axis, so they're not ever going to intersect. No y-intercept because they're parallel. If you have x only, there's no y, then you know that it's going to be a vertical line. On the other flip side, if you have y only, this could kind of also be written as y equals 0x minus 2. And we can see that the slope is 0. The slope is 0. the y-intercept is -2. And if the slope is 0, that means we don't count rise up or down. So it would be kind of like 0 over 1. Because remember, I told you if it's a whole number, you can put it over 1. So we're not rising any, and we're going over 1. We're not rising, or we're not going up or down, so we're going over 1. And you can see that this would make a horizontal line. Horizontal line, while it has a y-intercept of -2, it doesn't have an x-intercept because it is parallel to the x-axis. So again, if you have a special case, we've gone over special cases. If you have only one variable, then it's going to be one of those special cases. All right, we are going to practice more with graphing in class.